Thanks, Peter, and hello, everybody. So today I'm going to talk about digitalization and how this is connected to the energy transition. Next slide, please. So we are in a major revolution, a revolution for the energy systems. Decarbonization is one topic which drives our generation, which originates from global warming and the Paris Agreement to limit global warming to 2 degrees Celsius. In Europe, we have agreed on the Green Deal, where the goal is to be net CO2 neutral free by 2050. We are already on the road of decarbonization, and it's predicted that renewable go up by 40% by 2030. In turn, this will also mean that with the installation of renewable and storage solution, our power generation will become more distributed. And we already see that nowadays. We are looking at two major drivers which will transform our energy system. And these are the decarbonization and the decentralization. Decentralization is already a reality and is shaping the present and the future of power generation. Flexibility will be a key success factor for all power producers. So let's jump back and see where we're coming from. This is how the energy mix looked 20 years ago. Large thermal plant generation provided via the grid distributor. This grid could be treated as a big copper plate. Bilateral contracts, including power exchange transaction, accounted for the vast majority of generation volume. Basic reserve markets and frequency response are used to fill in any surplus of or undersupply in the market and to make up for events such as emergency plant shutdowns. In 2020, the generation mix has changed completely. Relatively unpredictable renewable energy has increased massively. A large amount of distribution connected generation has been added. The old reserve markets and ancillary services are unable to efficiently account for generation and demand fluctuation, yet account up to 15% of the power supplied, greatly increasing cost to consumer. And what happened now? The balancing capabilities of the distributed generation is completely untapped. So let's do a jump in the past. This is how the energy mix looked 20 years ago. Large thermal generation provided via the grid of two distributors. The grid could be treated as a big copper plate. Bilateral contracts, including power exchange transaction, accounted for the vast majority of generation volume. Basic reserve markets and frequency response are used to fill in any surplus or undersupply in the market and to make up for events such as an emergency plant shutdown. In 2020, the generation mix has changed. Relatively unpredictable renewable generation has increased massively and large amount of distribution connected generation has been added. The oil reserve markets and ancillary services are unable to efficiently account for generation and demand fluctuation, yet account up for 50% of the power supply, greatly increasing cost to consumer. And what happened? The balancing capability of the distributed generation is completely untapped. TER, which is the Trans-European Replacement Reserve Exchange, provide a solution for these issues, along with other domestic ancillary services. TER is the European implementation project for exchanging replacement reserves in line with the electricity balancing guideline. The aim of TER is to build the replacement reserve platform and set up the European replacement reserves balancing energy market in order to create an harmonized playing field in a market participant. As you can see, this is completely digitalization entering our generation market. Next, please. And now let's see how the road to decarbonization and to the future look like. Imagine a world with zero CO2 emissions. Imagine if power is generated only from renewable resources and used in all sectors of public life. How can we get there? Simply, step by step. I will show you how the road to decarbonization looks like. Let's start with something that lowers CO2 emission immediately by increasing efficiency, for example, through upgrade of gas turbine, optimization of combined cycle power plant, and continuous performance optimization, likewise the startup and shutdowns. Where renewable come into play, we have to think about flexibility and short-term storage solution, which can balance load difference which comes from rotating renewable in feed, or add black start capabilities. We can also provide efficient heating, cooling, process steam from thermal power plant with combined heat and power, or by adding industrial scale heat pumps in combination with renewables. The further we walk down the road of decarbonization, the larger the share of renewable in the mix. This brings new challenges, and we need to further improve flexibility and grid stability. Implementing a synchronous condenser or a flywheel is one way to compensate the power fluctuation. Renewable battery storage and heat pumps is one way to enable the development of more and more CO2 neutral decentralized hybrid solution. And we will talk about the hybrid solution also later on. A backup for conventional sources will be still needed when the sun, for example, doesn't shine and the wind doesn't blow. So now it is when we add electrolyzer into the equation. They turn excess power from renewable into H2, which can be stored in large quantity. This creates entirely new options. Gas turbine can be co-fired with hydrogen and natural gas. With renewable at the heart of our energy system, storage systems become essential. This is where short-term battery storage and mid-term thermal storage solution using heat, pumps, and long-term green hydrogen storage will come into play. Imagine the scalability when we add more sectors to this, like the industry or mobility by generating e-fuels. And later on, we will go into a real example how we generate e-fuel nowadays. Next one. So, and now let's see how the digitalization is supporting our systems. So we come, as we saw, from the fossil power, conventional power generation, and we wanted to go to a CO2 neutral, hybrid, decentralized solution. So what we need to do is to go from a classical distributed control system with a number of IOs and some automation server and a central control room to a completely new system that is scalable, where we have different rooms that we are remotely connecting in a virtual control room, and there we come to a virtual power plant. So any system that is powering that must be a virtual power plant compatible system. And of course, we have the big challenge of the cybersecurity, which is not just a cybersecure application, but is we need to manage the distributed cyber security of all the assets that we have. So, and this is powered by what? Digitalization, of course. So you can see already how digitalization is shaping and changing the world of the generation of energy today. Next. And as I was talking about the virtual power plant and the virtual power control, we can see that instead of having just one asset that you have to control, you have different distributed assets that are produced from 1 kilowatt to 100 megawatt and more, and you have to connect them together. So, of course, you will need to have a distributed control system that is a virtual power plant controller. This will enable us to participate to the central hybrid power generation market with advanced function like the integration of hydrogen into thermal resources, the dispatcher optimizer. This is crucial for the next generation of power, and also the load forecasting. And we are going also into that a little bit more. So how do we see the decarbonization impacting the generator markets? It's not just the generation itself, it's also the transmission and the transmission utilities that need to change and get digitalized. As we see, the digitalization is becoming more relevant for the complete chain of the production of energy. And we need different systems that are helping us. We see already that, for example, in France, national platforms are starting popping up, like the FCR. We have the minute reserve in Germany and the balancing mechanism in Great Britain. So these are all digital platforms created to support the transmission and of the energy into these countries. And we have also a lot more increased cross-border energy flows. So for taking advantage of that, we need international exchanges. Likewise, the TER that I was talking before, where 7 TSO are replacing the reserve instruction. And we have also the Picasso and the Mari platform that are really taking care of manually activating resource instruction or supporting up to 27 TSO to transport the energy. And now we come a little bit more into what does it mean now taking care from all this generation that is fossil, that is green, that is renewable, that is hybrid. What do we need? We are going into a CO2 neutral world. So the sustainability certificate for the energy market are very, very important for every power producer. Unfortunately, nowadays, there are no standards there. And this is a new field that is popping up, and we need really to take care of it and shape it. So currently, the only proof of energy origin are, for example, the green and electricity labels and the green gas certificates. Hence, there is an imminent lack of a reliable system with uniform sustainability criteria. So this is exactly where digitalization kicks in. Current solutions cannot be combined with each other, and thus do not meet the future requirement of a holistic energy system that take end-to-end consideration into account. Sustainability is a new customer demand, and digitalization is helping the customer in creating this value and bringing the CO2 certificate into life. On the other hand, every industry is called upon to generate a contribution to climate change. The challenge is to give the parties involved the opportunity to develop new business models to refinance contribution against climate change. Honest and comprehensive guarantees of origin are needed as a basis for the development of new business models. And issuing the administration and the transaction and validation of the certificate involve manual effort. Due to the amount of the manual work involved, the current system will not manage balancing in shorter time intervals, which is necessary for a more accurate tracking of the green energy. So, what is needed to turn this idea of the future of energy and the trade business into a success? So we need for sure, as we said, new virtual power plant systems. We will need to add artificial intelligence to the system too. We are adding additional digital solution to the complete system. And as we say, we need a message broker to the TSO to put the data to use. So we need new digital solution like connectivity enable for really bringing the message broker between the TSO and the various plans. We need an operational planning suite to maximize the use of the asset of every customer, as well as a maintenance planner to really get in control of the maintenance schedule. And one of the most important things, I think, is the economic dispatch. So you need to be able to schedule the best of the operation, taking into account all the assets of the customer. Next. And now we come to one very interesting application of digitalization into the energy market. And these are the sustainability certificate for the energy market. As today, we have no standard for them. So currently, the only proof of energy origin are, for example, the green electricity labels and the green gas certificates. Hence, there is an imminent lack of a reliable system with uniform sustainability criteria. There is a missing interoperability. The current solution cannot be combined with each other and thus do not meet the future requirements of a holistic energy system that takes end-to-end consideration into account. The sustainability is a new customer demand. This is highly important for being really in the new markets. On the other hand, every industry is called upon to generate a contribution to the climate change. The challenge is to give the parties involved the opportunity to develop new business models to refinance contribution against the climate change. Honest and comprehensive guarantees of origin are needed as a basis for the development of new business models. The issuing, administration, transaction, and validation of certificates involve manual effort. Due to the amount of manual work involved, the current system will not manage balancing in short-term intervals, which is necessary for a more accurate tracking of the green energy. And there is exactly where digitalization will help us. Next, please. And now I'm going to talk about something that you will not think is applicable to the energy market, but where I think is going to be essential for the future, blockchain. So let's start from the beginning. As we said, there is still a fossil production and there is a green production, and we have this energy certificate. And how digitally are we going to take care of it? With blockchain. So the green energy deal for energy market is a distributed software service that issues automated, timely and governmental approved sustainability certificate for cross-domain energy market participants. Blockchain is the solution that ensures cross-sector traceability and participation at this new energy stock exchange. And now you will say, what is blockchain? Is that Bitcoin? Yes, but no. Bitcoin is just one of the many applications of the technology. Actually, blockchain is a distributed, decentralized public ledger, and it's a simple and fundamental internet protocol providing bare bones of ordering bookkeeping in a secure and auditable way. Blockchain is the technology that is enable these kind of things, but it's not a concrete product or service. And it's a blockchain, indeed, is a distributed database that keeps track of all digital data, free of defraud for the companies. As you can see, this is complete digitalization, and this is how digitalization is transforming the energy market. Without digitalization, there will be no transformation of the energy market. There is no energy market without digitalization. Next, please. And now I wanted to show you something that is a new reality. Wind of change are blowing very strongly in the south of Chile. And today I'm going to talk a little bit about the Aruoni project. It's a new reality and it's fuel from wind and water with a purpose to decarbonize the transport sector. As you can see, we go from energy to transport sector. So there is an interconnection of all the system that is incredible. And again, digitalization is the backbone of everything. Siemens Energy, together with other big companies, likewise Porsche, Enel, ExxonMobil, is developing and implementing the world's first integrated and commercial large-scale plant for the production of climate-neutral e-fuel. Aruoni project is in Chile and is harnessing the strong and steady wind in the Magallanes in the most southern part of Chile. We are committed to sustainability, and this project is one of the many important steps we are taking into decarbonized society. In Haroni, we are producing e-fuel, which will be supplied to Europe and other regions, and this is helping us in achieving the Green Deal. The Green Deal, as I said before, is the commitment of the European Community to raising the EU climate target for 2030 that will lead Europe to be the first climate neutral continent by 2050. Of course, the transport and industry sector are together responsible for 45% of the world's CO2 emissions. However, in these sectors, renewable energy sources have only reduced emissions by less than 8%. So decarbonizing the transport and industry is more complex and costly compared with the power sector. This is why the EU is now also gradually including the road traffic and the building sector into the emission trading scheme. In addition, the Commission plans to significantly tighten the CO2 fleet limits to passenger cars. This is exactly where, in combination with electrification, fuel generated from renewable sources will come into play. And this is one important application of the Power-to-X. Power-to-X means electricity is converted, preferably, of course, from renewable energy sources, to hydrogen or to anode-based synthetic fuels and feedstock, which will then be applied in several sectors. And now let's go into a little bit more clarity what the project is doing. Next. So we have seen the road of decarbonization. When we add the electrolyzer, this creates entirely new options. In Aruoni, we generate green fuel from wind and water. Together with the other international companies, this plant is able to produce green fuel that will power car in the future. How does it work? Electrolyzer are used to generate hydrogen powered from wind and solar parks, and then is synthesized within CO2, which is captured from the air to generate methanol and is then shipped to Europe. This is also exactly where, in combination with the electrification, we see really how the two sectors are getting together, how digitalization and new technology play a bigger role, and is one of the more important applications of the Power-to-X. As we said, this synthetic fuel is pretty much CO2 neutral, and it is a liquid energy carrier that emits about 90% less CO2 than the fossil counterpart. In case of e-gasoline, it is simultaneously compatible with existing liquid fuel infrastructure. In our Aruoni project, it's a demonstration of a broad spectrum of innovative, climate-relevant technology in one location. By channeling this powerful wind, we are making good use of the natural resources and exporting renewable energies in form of liquid fuels. This e-fuel will be then a big step toward in decarbonization of the transport sector. Without digitalization, without the new technology, this will not be possible. Let me tell you about the impact of it. So, in the pilot phase, e-methanol production will initially reach around 750,000 liters per year by 2022. Part of the e-methanol will be converted to e-gasoline, 130,000 liters per year. In step 2, capacity is planned to be increased to 55 million liters e-gasoline per year by 2024 and to over 550 million liters per year by 2026. And what does that look like? That's enough fuel for over 1 million people to drive their car for nearly 1 year. So, as you can see, the energy is not anymore just energy. Energy is changing the world. Together with digitalization, we are transforming the new energy market into the future. And we are interconnecting the different sectors to really create a sustainable energy system that will help us in the sustainability of our planet. Thank you so much for your attention.